it won't take us too long.
Oh, so now I'm multiplication.
A multiplication will be fine. And I occasionally see some of you looking at your assignment books for multiplication tables, and I would strongly suggest that you really try to learn your facts without that, because it will do nothing but hurt you in how quickly you can do a problem and how accurately you can do it. Let's just start by going back to, if we multiply by a one-digit number, let's say you have 35 times 5. What is the algorithm for doing that? We do it so much we don't even think about it. Remember, algorithm means the way that you do it. Ryan, you always
multiply the two numbers and then multiply the bottom number by the other.
yeah, you start with the bottom number times the farthest right number. In other words, 5 times, this is the units place, or the ones place. So 5 times 5 ones is 25. So you put the 5 down and you carry the 2. 5 times the tens place, okay, that's really 5 times 30, which is 150, believe it or not. But because we already have the ones place taken, we don't have to put that 0 there. 5 times 3 is 15, plus the 2 is 17. So really, something to think about is this. What you've done when you've multiplied this, you don't think about it this way, but really what you've done is 2 different problems there. You've taken 30 times 5, and you've taken 5 times 5. You've done both of those problems in one nice little easy piece here, because this is 25 and this is 150, and you've added them together kind of all blah, 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 blah. And I know you're a little confused at that, but when we do multiplication, we do it a nice short way rather than doing it really long. When you do double-digit multiplication, though, it's the same thing, but you have to follow the right algorithm, which I'm sure you did double-digit multiplication right before.
Yeah.
Let's say you've got 32 times 15. Okay. It starts out the same way. The algorithm is you take the farthest bottom right-hand corner and you start multiplying by that one first, just like we normally do. Think about it like 32 times 5. So that's your first step. What is 32 times 5? Well, 5 times 2, Brooke Kala is, yeah, and then 5 times 3 is 15, plus the 1 is 16. So you get the 160. That's like we've normally done, but what do we do now? And here's the part that a lot of people forget to do, okay? When you get to the second digit of the bottom, what do you have to do? When I get to because the next thing I have to multiply by is this other number right here, this 1. But before I do that, drum roll, Kayleen, I have to.
Put a 0 under the.
Exactly. You must put a 0 down in the units place as a placeholder. And the reason you do that, children, and it won't make sense to some of you, but the reason you do that is because this 1 here is not in a units place, it's actually in a tens place. So you're really taking 32 and multiplying it by 10. And when you do that, you always end up with a 0 there, and the 3, you're going to get 320, which is what we're going to get, because I dropped that 0 down. 1 times 2 is 2, 1 times 3 is 3, and then you add the 2 columns together, 0, 8, 480. Somebody at the door, or is that somebody knocking on the chair? No? Yeah, no? You've done this before, correct?
Yes.
All right, but it's always good to review because I know people, this is where I see if people made mistakes other than their basic multiplication, it is always right here. Anytime you have double-digit multiplication, there's going to be a 0 in that spot. Let's look at a really big problem. 75 times 31. Okay, so the first thing I do is multiply by which digit?
The what?
The 1. And what is 1 times 75? Now you end up with this. 1 times 5 is 5, 1 times 7 is 7. And here is the big issue here. The next step I have to do is I need to make,
Put a 0.
right, when I get to this digit here, when I get to this 3, because it's in the tens place, I need to put a 0 there before I start. And then I do the same thing. 3 times 5 is 15, carry the 1. 3 times 7 is 21, plus 1 is 22. And if you're not a neat person, you really need to do your best to line up all these columns, because when we get to triple digit multiplication,
Which is probably would be a little.
which is really the same thing, guess what happens when I have a third digit here?
You add them all.
Instead of adding 1 0 here, when I get to that spot here, I add 2 zeros. It's the same algorithm. Let's just look at one.
Except no one wants to. Okay. Can we do this one all first?
Can we try to do it?
Can we do this?
Listen, you can try to do all the stuff you want. I'm just going to do this real fast because I want you to see how the algorithm continues no matter how big the number is.
So we didn't have to write this?
You know, it doesn't matter. So the first thing you start off is in the ones place with the 6, and you multiply through 6 times 12, 36, 37, 3, 18, 21. Our algorithm says that when you get to the tens place, when you get to this one, which is next, you have to add 1 0 here. And then you multiply by the 9. 9 times 2 is 18, carry the 1, 54 plus 1 is 55, 5, 27 and 5 is 32. Now when you get to the third digit, which is in the hundreds place, you have to follow the same pattern. Instead of putting just 1 0 down, you have to take up 2 places, because this is in the hundreds place. So you start in the hundreds place. 5 times 2 is 10. 5 times 6 is 30, plus 1 is 31, and 3, 18, 15 is 18, and then we end up with 7, 5, 1, 2. 215,752. And 4 digits would be the same thing. You just add 3 zeros when you get to the
That
bottom.
seems a little.
I will give you one to try. Let's do one, just double digit.
Okay.
24 times 24. Go ahead, give that a shot there. When you're finished, raise your hand so I can take a peek there. Don't forget to put that 0 down. That's crucial. 24 times 24. You have to give me one thing. This is the one thing. Okay, people, stop. Let me tell you, those of you that made a mistake, it was just a goofy thing, and I know exactly where it came from, and it's an easy fix. Everybody got this. 4 times 4 is 16, and you got 96 there. Okay, and here's where you went wrong. 4 times 4 was 16. You put a 1 there. 4 times 2 is 8 plus 1 is 9. And everybody got this part right. But here's where like 5 or 6 people did this, and I understand it. Everybody got the 2 times 4 is 8. But then they did 2 times 2 and got 4. But see, this 1 didn't come from this multiplication time. It came from back when you did 4 times 4. So you have to make a special point that when you did this over here and got 96, that somehow you get rid of that 1 so you don't think it goes with this 2 times 2, because it doesn't. 2 times 4 was 8. There was no 1 to carry over with that part of the problem. 2 times 2 is 4. Those of you that got 5 saw that 1 up there and thought that, oh, 2 times 2 is 4 plus the 1 is 5. But that didn't come from this part of the problem. That came from the 4 part of the problem. So you have to be very, 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 very careful on that. How many people did that? Yeah. So you're not alone. Just make sure you get, if you have to, just erase it maybe after you do this, and so you know it's not there. Like when I did all this up here, this can get pretty confusing when you start doing stuff like that right there, because you don't know if that 3 came from. And that especially comes into play if you don't know your multiplication tables real well, and you have to take a break and think about something like that. So think about that. Take care.